Good afternoon, class. We are on to 7.2, Properties of Parallelograms. The key word in parallelograms, and I definitely spelled that incorrectly, is that they're parallel. Missing an L here, and that's okay. So parallelograms definitely have parallel lines in them. So that's what we're going to be talking about today. So let's go off with our definition of a parallelogram. It is a four-sided figure, and another name for a four-sided figure is that it is a quadrilateral. So it is a quadrilateral with both two pairs of parallel lines that are opposite of each other. So that just means that with a parallelogram, think of these as two sets of parallel lines. What's parallel to this line? Definitely be the base. And parallel to the top, or to the sides, will also be the other sides. There are two sets of parallel lines. This also looks very familiar when it comes to parallel lines, and we have sets of transversals. So please keep those angles in mind as we talk about them. So let's go through our theorems. We have parallelogram, opposite sides theorem. So with this, it's just telling us about their congruencies on parallelograms. So if a quadrilateral is a parallelogram, then the opposite sides are congruent. So opposite sides are congruent. So then for this one, for example, we have PQ is congruent to RS, and QR is congruent to SP. Okay, so let's try an example. So let's say I had a parallelogram. And no, it is not drawn to scale, but let's say this one is x plus 4, and our bottom one is 12, and then one side is 20, and my opposite side is 3y minus 1, and I want to find x and y. So let's start off with x. So going by our parallelogram opposite sides theorem, what is congruent to x plus 4? That would be 12 because it is parallel to it. So I would set x plus 4 equal to 12, subtract from both sides, so I have x equals 8. Okay, so note that these two are congruent to each other. So that means our sides are also congruent to each other. So if I want to find y, I'm going to set my opposite sides equal to each other because they're parallel. So I have 20 equals 3y minus 1. Going to add 1 to both sides, so I have 21 equals 3y. And when I divide by 3, 21 divided by 3 is 7. So y equals 7. So those are your examples for parallelogram opposite sides theorem. So for 7.4, we have the opposite angles theorem. So that means opposite angles are congruent to each other. So Q is congruent to S, where P is congruent to angle R. So opposite angles are congruent this time. So for this example, and note this example will show up again in a different way. I will have 6y in one corner and 2x in another. Now this one is 126 and 54 degrees. So, and let's label it A, B, C, and D. So what is congruent? Trying to find x and y. What is congruent to B, or 6y? Well, if we're going off parallelogram opposite angles theorem, what's opposite of Q was S, so what's opposite of B is D. So that means angle B is congruent to angle D. So that means 6y equals 126 degrees. So to find y, divide by 6, so y equals 21. Then, let's do the same thing for A. What's congruent to A? Well, that would be C. So angle A is congruent to C, So 2x equals 54. And when I divide by 2, x equals 27. And so that is finding x and y using opposite angles theorem. I'm actually going to repeat this problem on the next slide because then you'll see a pattern what happens with 126 and 54. So on to the next theorem. I have consecutive angles theorem, and think consecutive is kind of like adjacent, they're next to each other. So they're next to each other. Consecutive kind of means like one after the other. So P and S are consecutive, S and R are consecutive, Q and R are consecutive, and P and Q are consecutive because it's right next to each other. So PQ and PS, but you can't say P and R because they're opposite of each other. They are congruent, but they're opposite. So for consecutive angles, they are supplementary. And remember, supplementary means 180. So if we were to add up these two next to each other, they should add up to 180. So I'm going to rewrite that problem from the previous page. So I have 6y, and we said 2x, 126 degrees, and 54 degrees, right? So if these are congruent, we already solved the math for x and y. So we do know that this one is 126 degrees, and so this one's also 54 degrees now, based on the opposite angles theorem. So if I were to add these two together, they should give me 180. So if I have 126 plus 54, I get 180 degrees. Remember, this also works when you have parallel lines. And so if we were to add the two insides together, they also gave me 180. Okay, so consecutive angles theorem, same for parallel lines, same for parallelograms. So now I have parallelogram diagonals theorem. So this is talking about the lines that are cross in between. So this means that they bisect each other. So that doesn't mean this is congruent to that side. That means if I make this diagonal, obviously it's going to be longer than the short one. But if they intersect in the middle, that means that these two are congruent to each other, and then these two are congruent to each other. So, you know me in examples. So, let's say I had 5, 12x, 24, and y. And of course, I need to find x and y. So, according to my diagonals theorem, how would I find x? Well, what's congruent to 12x? Well, that would be 24, because it bisects this theorem. So I have 12x equal to 24, and I divide by 12, x equals 2. Okay? And now for y, if these are congruent to each other, that means y equals 5 as well. Okay, so now let's go into our practice problems onto the back side. So extra practice. Just find the value of each variable in the parallelogram. So we need to find x and y. So we know what x is, and you know what y equals. Okay, so let's start with x. What is parallel to this line? Well, it'll definitely be the other side, because parallel means they don't cross each other. And obviously the other two end up crossing this line eventually in life, or they intersect. So that means x plus 18 has to equal 3x minus 2. So I'm going to subtract x from both sides. I'm going to add 2 to both sides, so I end up with 20 equals 2x. And when I divide by 2, x equals 10. So no, x is 10. And then I need to know what y is. So I already know what x is. I know 4x equals y, because they're opposite of each other. However, x is 10. So that means I can plug in 10. So 4 times 10 is 40. So y is 40. Alrighty, so let's do the same for our other example. So we need to find x and y. So for x, let's try our interior since we already have a solid answer here. So what is congruent to our 49 degrees? That would definitely be our 4x minus 37 because of opposite angles theorem. So 49 equals 4x minus 37. Going to add 37 to both sides. And so I'm left with 86. I'm going to divide by 4. And so I'm left with x being 21.5. Alrighty, so now we have x. And look, x is definitely right here on number 2, or right next to number 2, and it's going to be congruent to y over 5. So I know that 4x, I'm going to put it up here due to room, 4x minus 3 equals y over 5. But I already know what x is. X is 21.5. So 4 times 21.5 minus 3 equals y over 5. Let's go ahead and simplify that parentheses before I get rid of the 5. So I have 21.5 times 4, which is 86, minus 3. So I'm left with 83 equals y over 5. And if I have something divided by any number, I can always multiply to get it out from that denominator. So I'm going to multiply by 5 on both sides. And so 83 times 5 is going to give me 415. So y equals 415. Alrighty. So this is where you're taking x and you just plugged it back in to find y. So now, number 3 is talking about the diagonal bisector theorem. So what is congruent to the 5y minus 16? Well, that would definitely be that 3y because they're definitely across from each other. You can always pair y's and y's and x's to x's. You can't pair apples with oranges. So I have 5y minus 16 equal to 3y. And then I have 2x plus 10 equal to 4x minus 2. I'm sure you already know how to solve for x, and you should end up with x equals 6 and y equals 8 at the end of the math. I'm sure you understand how to get those two, and if you don't know how to solve for x and y, please come see me for after school tutoring. So now we are down to, just to show you those are congruent, so now we are down to our 4 through 11, which is indicated in this picture, and we have to explain our reasoning on solving for sides or angles. So it says, first one says find PO. So PO is down here. And so what is parallel to PO? Well, MN is parallel to PO. So now PO is parallel to MN. And what is MN? 24. So that means PO must also be 24. And there's 24 because of opposite, and I'm abbreviating, sides theorem. Because it does say explain your reasoning, which means what theorem did you use to get that answer. So number 5 says we need to find OQ. So OQ is here. So what is going to be congruent to OQ? Well, it'll be MQ. These two are congruent to each other, so that means OQ is 14. And that is due to the diagonal theorem. Okay, so NO. NO is our next one. And what is parallel to NO? Well, that would be MP, which is 26. So NO is 26 due to their opposite sides. So it would be opposite sides theorem. Okay. So number 7 is PQ. And what is congruent to PQ? And that would be NQ. So that means PQ is also 20.7. And that's because of the diagonal theorem. Number 8, this is where we're talking about angles. So number 8 is asking for the angle measure of P and N. So it's asking for this entire thing. Well, I can't really do much with that 59, but I can do something with the 68. And 68 is this entire thing here. And no, they're not congruent to each other, but they are consecutive because they're right next to each other. So to find this one, if they're consecutive, that means I have to add to 180. So if I take 180 minus 68, then I get 112. So that means angle M, or PMN, is 112 degrees. And that's because of consecutive angles theorem. Alrighty, so remember with consecutive, that means they add to 180 as a side note. So now number 9 says find angle NOP. So note the best way to kind of figure out what angle you're talking about, think about that middle letter they're asking for, and it's asking for all of O, not just NOQ, this half of it, they're asking for the entire thing. And we know that's going to be 112 because of opposite sides, or opposite angles theorem. So number 9 is 112 because of opposite angles theorem. And then number 10 says we need to find OPM. So OPM is this entire angle, and that's going to be congruent to N, or all of N, which is 68 degrees. So at 68 degrees, again, the same reasoning, it's for the opposite angles theorem. And our last one is asking for NMO. So it's asking only for this part. Now note, these are not necessarily half. It doesn't mean these two are congruent to each other. It doesn't bisect the angle, it just bisects the diagonal, so the side. So, if we notice what looks familiar, if we have parallel lines, what happens if I'm just looking at these two? Well, they're congruent to each other. And same for these as well. So, if this is 59 degrees, that means M and O, so just this part, is also 59 degrees. So this is 59 degrees because these two angles are, especially for here, alternate interior. So alternate interior angles theorem. So we haven't done that one in a while, but it still applies. So alternate interior angles theorem. And that was our last question of our notes. On the other side, you do have a puzzle. Please feel free to go ahead and do it if you feel like you got the time. We try to kick it out in at least 10 minutes of class. But if you have the time to do it now, please go ahead and do so we can stay ahead. And we can always have free time to do extra practice and other matters at the end of class. Thank you so much.